5a. Outline the mechanism by which a gas such as carbon dioxide absorbs infrared radiation. Now, the thing with carbon dioxide and infrared radiation is that the natural frequency of CO2, carbon dioxide, is about the same as is equal to that of the frequency of infrared radiation. So because it's at this natural frequency, it means that the CO2 will absorb the infrared radiation, and because it's going to absorb that radiation, you get a resonance effect. You get the CO2 molecules will move rapidly to and fro. They've got kinetic energy, and then they will re-radiate that energy, and so it stores, traps the energy, and re-radiates that energy within the atmosphere. So state with reference to your answer in A why carbon dioxide is known as a greenhouse gas. Well, because it traps or it absorbs the infrared radiation, and it is not all lost into the atmosphere, or goes straight through. It doesn't go straight through the atmosphere, but it is trapped by this carbon dioxide. It is known as a greenhouse gas. So because it absorbs or traps the infrared radiation and re-radiates it to the surface of the earth. State the name of another greenhouse gases. Well, there's a whole number of those. You get water vapor is one, methane gas is another, you get your nitrogen dioxide, and so forth. So all of these are greenhouse gases. It says in the last 50 years the amount of carbon dioxide in the Earth's atmosphere has increased significantly. Explain why this increase could account for global warming. Well, because we have, in this one over here, because we have most of the greenhouse gas, because most of the energy is not escaping but is being trapped by the carbon dioxide. So the CO2 traps the infrared radiation. Because it absorbs that, it can lead to an increase in the temperature. And what effect has this had on the average albedo? Well, your albedo is your total scattered power, total incident power. Now, because this has got less, because there's less energy that is reflected and going out from the whole Earth system, energy system, because that has gone down, your albedo has actually decreased. So it's a 3-mark question here, so you've got to make sure that you've got supporting evidence. So your albedo decreases, it goes down, and that's because the scattered power decreases because you have more radiation is absorbed in the atmosphere. If you just took a guess with this and just said it decreases, but you gave no supporting evidence, you would get 0 for that question. Continuing over the page here, it says it has been estimated that doubling the amount of carbon dioxide in the Earth's atmosphere changes the albedo of the Earth by 0.01, and we know that would lead to a decrease by 0.01. Use the data to show that this doubling will lead to a change of about 3 watts per meter squared in the intensity being reflected by the Earth into space. So we get here, over here, we get the average intensity received at the Earth's surface from the Sun is 340 watts per meter, and the average albedo. So if I take that using this formula over here and I call this x is equal to your albedo at the moment is 0.3 times 340. If I multiply that out, I get to about 1.102 watts per meter squared is actually being reflected out of the Earth system. And if we change the albedo, and it'll actually go to 0.29, because as we showed earlier, it actually leads to a drop in the albedo, times 340, you get about 98.6. We get about 98.6 watts per meter squared. So we would get a difference therefore of about 3 watts, about that amount, because we're going to get 102 minus 98.6, about 99. So 102 minus 98.6 is approximately about 3 watts per meter squared. And state one reason why the answer in E is an estimate. Well, we're assuming here that all the radiation that is being reflected is infrared, and therefore you're getting it all being absorbed, and that all this extra gas is actually absorbing infrared, and also that you're going to get probably with an increase of temperature, as your temperature increases, the amount of radiation will increase. So that may lead to a greater increase in the amount of radiation leaving the Earth's atmosphere.